Hello and welcome to part 2 of our practice problems, class problems for chapters 3 and 4. So we left off at number 8. On this video I'm going to do just a couple problems because I want to leave the last couple for their own video so we don't run out of time in the middle of them. So let's get started. So number 8, suppose the following are the ages of group individuals enrolled in a study looking at the relationship between sleep apnea and Alzheimer's disease. So here we have our data set, right? And if we want to count, you can most certainly count. I will help you out here though, but we know we have n equals 18. There's 18 data points here. And they are not in order, but as you can see, we need to create a stem and leaf plot for the distribution of the ages in the study. So we're going to create a stem and leaf plot. All right, so we can kind of look at the stem and leaf plot. And of course, there's many different ways you can do stem and leaf plot, depending on how much you want to break it up. For this one, though, we don't need to do too many crazy things. It's just a very straightforward stem and leaf plot where we're going to be using the stem of 6, 7, 8, and 9. And I don't see anything above 9, or I don't see anything below 6, so this will be our stems. Now, the next important part for stem leaf plot is making sure you get all the numbers in there. So remember, we have a total of 18. We already know, so we know when you have 18 leaves here. With big data sets, I think crossing them off sometimes it just looks too messy when you start crossing them off and you miss digits and you just do this. You can't tell. I don't know. It doesn't look as good to me. So I'm here to offer something else. I mean, if that works for you, great. I'm all for it. One thing that I think can work is changing it up a little bit. So one thing I did was anytime I was looking for 6s, what I did was I boxed all the 6s. Boxed all of them up. Let's see. Oh, and then there's one right here. So there's our 4. And then once they're all boxed up, you can kind of see that we had 61. Remember, you want to put these in order too. 65, 67, 68. And instead of not marking them off, I boxed them up. And I think that might help. And so then our next one is 7. So what I did for this one is I put triangles over them. And I thought by putting triangles over them, it makes them a little different, and you can kind of see the difference between boxes and triangles, and you can write them all out. Now we have all those. We know it's going to be 72, 72, 73, and 78. And then for the 80s, what I did was just to keep things, I underlined all the 80s here, or the stems that are all 8. And you can see there's quite a bit of them. And then working them out, 83, 83, 4, 5, 5, 6, 7. And then, the last one is 9s, and all the 9s are blank. You can kind of see that they're all there. So we have your 92. I'm going to put a little 92, 98, 90. And so we can all write those out. And then I think that's a little easier to see them all as opposed to cross them off. But if you like cross them off, 100%, do what works for you. I'm just offering different ways to look at them. All right, so we know we had 18 numbers. So let's see if our stem and a leaf plot here had 18 as well. So we know we had 4 in the first group here. 4, that's 8. Come down. That's 4, so 12, 13, 14, 15, 16, 17, 18. So there's 18 numbers here. Our n equals 18. So here's our stem and leaf plot for distribution. I think this one's fine. If you wanted to break it down more, of course you can. I don't think it's necessary because we're not trying to describe anything and we're just creating stem and leaf plot right now. And I think you can kind of see the shape of it, a little bit right there. And that's all we need to do moving forward. Moving on to number 9 here. So number 9, we're looking at the chart below and answering the questions that follow. So here we have 3 middle schools, and we have a BMI program before and after the middle school here. So we have Alice and Boels and Ocean Palms. So we have BMI before, BMI after, and one thing we want to know is how many individuals are we looking at here. So we should definitely always label this 6, 7, 8, 9, 10. So we know we have 10 individuals at each school going around. First thing it wants us to do is calculate the average BMI for each school before and after the intervention. So we need to calculate the average for each school. So the way we do that is we add up all the BMIs before. So we're going to add up all these values here. When you add them all up, you get 232. And you divide that by 10, the total number there, and that's going to equal 23.2. That is your X bar, that's your average. You do this for all of the values here, so this is going to be 218 divided by 10, which is going to give you 21.8. Moving on, 204, this would be 20.4, 198, 19.8. In case you need to see that, remember we're just adding up all the values for the before and dividing by 10, and then that's how we're getting our average, 22.9, and then 219, which is then 21.9. So here we go. Here are the averages for BMI each school before and after the intervention. That has been done. B is calculate the average loss in BMI for each school. So now we're going to calculate the average loss. All right, loss, so it's going to be subtraction. So we're going to take your 23.2 minus 21.8, right? You want to see how much you actually lost, and you get 1.4. And this is going to be at we're going to abbreviate it, the Alice BL middle school. And the next middle school for the Bowles private middle school is going to be 20.4 minus 19.8 equal 0.6. And this is for the BP middle school. And then our last one is going to be 22.9 minus 21.9, which equals 1. And this is for the Ocean Palm Middle School. So that's the average loss. C is which school seems to have shown the most improvement after the intervention. So if we're looking at weight loss, right, our BMI, and taking that into consideration, would have shown the most improvement. Well, the most improvement would be the largest number here, and that's going to be the Alice B. Landrum Middle School. So we would say that the Alice B. Landrum Middle School showed the most improvement with a 1.4 BMI loss. All right, and that is number 9. So let's go to number 10 real quick. Number 10 is the researchers interested in testing a new antiretroviral medication in a clinical trial to investigate its ability to stabilize or increase the patient's CD4 cell count. In order to test this treatment, the researcher recruits 10 patients into a study. The following table illustrates the CD4 count for the 10 patients at baseline and after follow-up. What is the average CD4 count for the patients at baseline and after follow-up? So we just want to find the average here. So once again, when we find the average, we're going to add up the total number of individuals for their CD4 count, divide by the total number of individuals there, and we get our average. So one thing we want to do, well, how many people are we dealing with here? So we're going to number the sides here, 10. So we know n is going to equal 10. We're going to add up. If you add up the sum of all the CD4 count here, you're going to get 3,294. We're going to divide that by 10, and you're going to get your X bar equaling 329.4. So our X bar is going to be 329.4. Same thing here. You're going to sum up the CD4 count following it. It's 3,453 divided by 10, and you're going to get 345.3. And there we go. That is our average CD4 count at baseline and follow-up. So number 11 here, I'm going to save for the next video because I don't know exactly how much time is left, but I don't want to run out of time during the middle of this, and then do the last couple problems as well in the next video. So this one was really short, but I want to make sure there's plenty of time to go over these next ones in full detail.